Hi everybody, this is the study guide for polynomials, high order polynomials, part 1. So we are going to be talking a bunch of things. The first section is going to be about the relationship between zeros and factors and roots and all stuff like that, at least for these problems. So let's go ahead and get started. It says, what is the factorization of this thing given that f of 1 is 0? What that means is that it's telling you that 1 is one of the solutions. And if 1 is one of the solutions, then that means you can use this. Well, first of all, I suppose if you want to kind of get it over with, if there's a solution of 1, that means its factor would be x minus 1. You always switch it, so 1 would be x minus 1. So that's one of the factors. But the other thing you're going to do to find the other ones is you're going to take that number 1 and you're going to use it on synthetic division. There are a bunch of problems in this packet that use synthetic division, but that's what it's going for here. If it's a 0, it's equal to 0, and use that 1 out there. You're going to have 3 lines of numbers to do synthetic division. This next line is going to be all of the coefficients, and you always want to double check that all of the exponents are present, because sometimes they're not. In this one, it goes 3, 2, 1, 0. So everything is there. There's no missing x's. So you're just going to do the numbers in front. 3, positive 2, negative 7, and 2. 3, positive 2, negative 7, and positive 2. And that is how you set up synthetic division. The way you do it is you take the 3 and you drop it down. You then do 1 times 3 is 3, and you put it underneath that and you add. So 2 plus 3 is 5. And then you multiply again, and that'll go underneath the 7. So 1 times 5 is 5. And then you add again, and you get negative 2. And you just keep going with that. You would, however many numbers there are, you multiply, add, multiply, add, multiply, add. And you just keep going until the end. 1 times negative 2 is negative 2, and they add up to 0. And you block off that last number. So always make sure that this is 0. It tells you it's 0. So if this is something else, then that means you must have set something up wrong. So there you go. This verifies it's a 0, and then it says what is the factorization. These numbers are going to be the coefficients of your answer. So the 0 you don't need to use. This minus 2 is going to stay a regular minus 2. This 5 is going to be a 5x, and this 3 is going to be 3x squared. And that is going to be one of your factors. And the other one we talked about already was x minus 1. So that would be in factored form. What is the factorization of that? We can double check to see if you can factor this. If not, then you're done. If you can factor it, you'd factor it. So we'll just check it real quick. 3 times negative 2 is negative 6. And 5. So is there anything that multiplies to 6 and adds up to 5? Let's see. 1 times 6 and 2 times 3 both multiply to 6. And if you want it to add up to 5, you could do a positive 6 and a negative 1. So this one is factorable, so you would have to factor it. So going over here, negative 1x and positive 6x is what it would factor into. So I would write 3x squared, and then instead of 5x, negative 1x plus 6x. So instead of 5x, you put that, and then minus 2. So the 3x and the 2 stay the same, but the 5 becomes negative 1 plus 6. And then you can factor it by grouping. So here you can pull out an x, and you get 3x minus 1. And for 6 and 2, they both have a 2 in common, so you can pull out a plus 2. And then if you divide this by 2, you get 3. And then 2 divided by 2 is 1. So you get x plus 2 and 3x minus 1. Meaning your final answer would be x minus 1. 3x minus 1, and that x plus 2. There you go. So this part factored into those two, and that x minus 1 just comes over. So that is the complete factorization of number 1. Number 2, list all possible zeros of this thing. Please make sure you are noting the word possible. It's italicized for a reason. It is very important. It is not asking for the actual zeros, so it's not like plug it in your calculator and get an answer or something like that. It is the possibilities, and it's quite possible that if you list out all the possible ones, none of them actually work, because you're only listing out possibilities, which, come to think of it, it should say all rational possibilities. Yeah, my bad. Simplify all answers and do not repeat. So the thing we learned in class is P over Q is what they call this. Why do they use P and Q? No idea, but they do. Where P is this last number, the constant, and Q is the first number, the leading coefficient. So in this case, you would have 8 over 4. I don't use the negative because it doesn't matter. All of your answers are going to be plus or minus anyway, so it doesn't matter. So you're going to list out all the factors of 8 divided by all the factors of 4. So everything that goes into 8, 1, 2, 4, and 8. And all the things that go into 4, 1, 2, and 4. After you do that, you have to write out every single possibility here. That is 1 over 1, which is 1, 1 over 2, which is a half, 1 over 4, which is a fourth. And then you keep going. 2 over 1, which is 2, 2 over 2, which is 1. But since 2 over 2 is 1, we already wrote it, and it says don't repeat. I'm just not going to. 2 over 4 is a half, so I'm not going to write it. 4 over 1 is 4. 4 over 2 is 2, and 4 over 4 is 1. So 2 and 1 are already listed. And finally, 8 over 1, 8 over 2 is 4, and 8 over 4 is 2. So those are both done already. So there you go. We just slap a plus or minus in front of each of these, and we'll be done with this question. Those are all of the possible rational solutions. It's physically impossible for all of them to work, so only some of them to, if any, maybe none of them work. They're all irrational. Who knows? Who cares? I don't. So let's move on. Number 3, given that a polynomial is this thing, and it has exactly 2 imaginaries, okay, 2 imaginary zeros, how many real zeros must it have? Well, the thing is, in any polynomial, the highest exponent tells you how many solutions there are. So there are 6 solutions. This does not include, or does include, depending on how you think about it, double roots, triple roots. It's because like it says there's 6 solutions in this one, but maybe 2 of the solutions are the same number. That's possible, like 2 and 2 are both solutions, but it's not counting that. So there's 6 solutions total, and it says 2 are imaginary. So if you think about it, there's 6 total, and there's 2 imaginary. How many have to be real? That's 4. Woo! Because if 2 are imaginary, then the rest have to be real. So 4 would get you that 6. So the answer is just 4. So it's an easy question if you remember what it's actually asking for. Okay. Last question on this page says, which of the following could be a graph of a polynomial if its degree is 3 and its leading coefficient is 5? So degree 3, you can already eliminate 2 examples because this is a degree 1, 2, 3, 4. This is degree 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. So already can't be A and B because those are degree 4. After that, it says the coefficient is 5. The 5 isn't really useful in itself. The only thing that you care about it is that it's positive 5 versus negative 5. And since it's positive, that means it has to end going up. That's true of any graph. Like this one right here would match the whole 5 part because it's positive and it's going up at the end. This one's going down, so once again, it couldn't be this. This one's going down, so it couldn't be that. But this one right here is going to positive infinity on the right side, so it ends going up. So D is going to have to be the answer, because it's degree 1, 2, 3, and it's positive. And that's it for the first video. So we'll come back and we'll do the next side.